Before we begin the titration problem, I want to remind you that your first job is to figure out which method you're going to use. The first one is a weak acid with a strong base titration. So we know we're going to get a titration curve that looks like that. We have 4 spots. We have the origin. What's my original pH? And when I use that, I'm going to use the Ka expression. So like the first problems we did, I'll use this expression to find the concentration of hydrogen ion, and I'll use that to find the pH. Then all the way through here, I have the effect of buffering. So from there all the way over to here, I'm going to use the Henderson-Hasselbalch equation because I'm going to have significant concentrations of both the HA and the A-. There's a sweet spot, which is 1/2 way to the equivalence point. That's the sweet spot where pH equals pKa. So when I'm doing a titration problem, I'm going to be on my lookout for the sweet spot halfway to the equivalence point. I've got the equivalence point, and that's going to be where the amount of OH added is going to equal the amount of H plus that was there at the start. Not just H plus, we can actually say it equals the amount of HA that was there at the start. After that, it's just dilution. So when I look at the details of the first titration problem, is that I start with 250 milliliters of 0.450 molar acetic acid, which is HA. HA because it's a weak acid. I'm going to titrate it with sodium hydroxide, which is going to be 0.800 molar. So now I'm all set to begin my process. That if I can tell where I am on this curve, I can pick the right equation to use and answer the question, what's the pH or what's the volume?